The third scenario is when this force maybe is now directed where? To the fourth quadrant. You are having our angle here, we said 35 degrees, then the force is in this direction, like this. So our free body diagram is still horizontal plane, so we have normal force, Fg, then here we have now force applied is now downwards, and frictional force is still in the same direction, opposed motion, the one we are looking for. That is our free body diagram, 4 marks for Mahala. Right, now, we now gonna calculate the frictional force. We say Fk equals to mu n as usual. It's there in the formula sheet. Right, but our normal force here is gonna be affected. That the scenario where I said you are pressing something towards the ground. Could be a chair, could be something that you are pushing. You are pushing. Scenario number 2, you were pulling. So here you are pushing. So you are sort of like pressing the object against the ground. So obviously frictional force is gonna be much more higher. Alright? So you can see that this Fy, if we are to resolve it to the vertical, it's gonna be here. We can label it as Fy. I don't think we need to construct again. You now know how to construct. Use the triangle, construct here. So Fy that we are looking for is the opposite, right? Opposite over hypotenuse, Fa. So it means we are saying for normal force is now normal force upwards should be equal to force in downwards, Fg plus Fy, which is gonna give you normal force equals to mg plus Fa sine theta. Right? That is it now. They are adding. Therefore, frictional force will be equals to mu n, where there is n, you put mg plus Fa sine of theta. Fa sine of theta. You see? So that is the third scenario. That is the third scenario that we are having. That is the third scenario. The last scenario, so we are now having an object on an inclined plane. Inclined plane. This is an inclined plane where we are having our object, same mass 20 kgs, coefficient 0.2. Then let's say there is force applied in this direction. So this is now our ground, the reference point. Our angle here will be having angle what? Angle theta. Let's just say, let's put a value, okay, theta. Angle theta, right. So our free body diagram, we're gonna have this, then it's an incline. So we are having force applied here. If it's going upwards, friction is in the opposite direction. Fg is always what? It's always vertically downwards, and then normal force is always at 90 degrees here. 90 degrees to the surface. Normal force. Right. That is our free body diagram. Right. Then when something is moving up, obviously there's no way it's gonna sink or move upwards. No ways. Why? It's because here normal force is balancing with what? Fg perpendicular. And here we will have what? Fg that is parallel to the plane, the one that causes objects to move backwards when it's going up an incline or to slip downwards. You see, so that is Fg parallel. Then Fg perpendicular, it balances with normal force. That's the reason why here, when we are calculating frictional force, you're gonna say mu n, right? Mu n. But our normal force in this case is going to be what? Fg perpendicular. Fg perpendicular, we don't have time to resolve it, but when you resolve it, that is the one that is equals to m, that is equals to mg cos of theta, right? So Fg perpendicular equals to mg cos theta. Fg parallel is equals to mg sine of theta. You need to know these formulas, very important, especially the one for Fg parallel, right? So this one is gonna be normal force equals to what? Normal force equals to Fg perpendicular. Therefore, normal force equals to mg cos of theta. When we back substitute here, it will give us Fk equals to mu, where there is n, we are putting this mg cos of theta. That is it. That is the last scenario. Those are the questions that we are having. Yes. Alright. That is it. Right. There's a question here that we can tackle. Is saying a crate of mass 2 kg is being pulled up to the right across a rough horizontal surface by a constant force F. The force is applied at an angle of 20 degrees to the horizontal as shown in the diagram. Draw a free body diagram, 4 marks. I have here the fourth scenario. I have I have flu, so forgive me. Right, so what we are having is this scenario where we are having force applied going there at an angle of 20 degrees. Then the force applied we are not given. Then they say it's of mass 2 kgs. Right. Then, as shown, draw a free body diagram. So a free body diagram, we are okay with it, all of us. So there is what? Normal force as usual. Down there is Fg. Then in the first quadrant, there is what? Force applied and obviously friction. So each force will have a mark here. Each force will have a mark. Now they are saying a constant frictional force of 3 newtons. So frictional force is equals to 3 newtons. X between the surface and the crack. The coefficient of friction between the crack and the surface is 0,2. Mu equals to 0,2. I don't know if you are able to see the question. 0,2. And then calculate the magnitude of normal force acting on the crack. So we want to calculate the magnitude of normal force. So we are using scenario number 2, I think. Scenario number 2, right? Where we are going to do what? You are going to, obviously normal force is going to be affected by Fy. So this will give you normal force plus Fy is equals to mg is equals to Fg. They are balancing like this, which is going to give you normal force is equals to Fg minus Fy, which is going to give you mg minus, here we said Fy is going to be what? Fa sine of theta. So in this case, it's going to be 2 times 9,8 minus F times what? Sine of 20. That is it. So this will give us 19,6 minus sine 20. Sine 20 is how much? Just write it as it is. I don't have my calculator. Sine of 20 F. Right. That is our normal force in terms of F. But we don't have the force applied. Now the second question was asking us to calculate F, the force. So to calculate the force here with a constant force, the object was moving with a constant force. So to calculate F, they gave us frictional force. Alright, and coefficient of frictional force, so it's easy. It means we are using the formula for friction, which is going to be Fk is equals to mu n, which is going to give us Fk is equals to mu, then here normal force is this one, 19,6 minus sine of 20F. So that will give us friction. They say it is 3 equals to 0,2 times 19,6 minus sine of 20F. Then you make F the subject, the formula. So if you don't know the scenario, then you won't do anything. This question, you think that the exam is difficult, whilst it's not. So you just need to go through these scenarios, take your time and watch this video, and then you will thank me later.